interpreting graphs of proportions. I like this one. The first thing that I'm going to cover, you really need to pay attention to because I think it's an area for or an area of concern for a lot of students because they look at it and they don't understand it. And I'm going to really try and explain this well. So pay attention to this. 2 points. This is what I'm going to write first. 2 points need, and what I mean by points is ordered pairs. Okay, so 2 ordered pairs need to be on a graph in order for it to represent a proportion. The 2 points that need to be on the graph are these. This one, 0, 0, which I think is easy. That's the origin. But then this one is where students get confused. This 1, R. What this is the unit rate or the constant of proportionality. Constant of proportionality. They're the same thing, unit rate and constant proportionality. Now, let me show you on a graph. You go like this. And then I'm going to have a line that goes like this. And I'm going to have a point on this line. Let's say this point is 10, 20. Okay? Now, when you look at this graph, automatically you could tell that it's a proportion because the line is straight and it goes through the origin right here. Remember, the origin is 0.00. So that answers this part right here. But what about that 1R, that unit rate? What in the world does that mean? All right. Well, if I wanted you to find the constant of proportionality here, you should be able to do it by using the point that is on the page. Remember that this is your x value, this is your y value, and for the constant, which we call k, we do our y value over our x. So this is equal to 20 over 10. Now this could be written as just 2 or 2 over 1, right? Are you with me so far? Okay, because this, I'm going to bring it down here, 2 over 1, remember that this is your y and this is your x, would give you 1 for your x, which represents this one right here, and then this part right here, the r, is what your constant is, the 2. And so there's 2. So in other words, on this graph, I have 0, 0, the origin, but then I also have 1, comma r, or in other words, the constant of proportionality. The unit rate is also on there. And if you think about it, the constant of proportionality, or the unit rate, or you can even call it slope, it talks about how steep the line is. So it would have to be on there. Okay? If you need to play that again, play it again. Make sure that you understand it, though, because in order for it to represent a proportion, you need to have 0, 0, which is the origin, and then you need to have 1 for your x value, and then whatever your constant of proportionality is, or unit rate. And we call that r here, okay? But it really should be k because we've been using k all along. But you get the idea. Let's move on. Here I have a graph. I want you to copy this down your graph, so pause the video right now. I expect to see this in your notes. Pause it. Okay, looking at this one, the first question. Are the gallons of water used proportional to the time spent in the shower? And how do you know? Well, yeah, it is. And how do I know? Well, duh, it's straight. And it goes through the origin. Right? This we know. Cool. I can handle this stuff. Well, let's do some more questions. Now I have the same graph on every page, but just a different question. I want you to write these questions down too, okay? These are the type of things that you'll be answering in class and on the test. Moving on, here's another question about the same graph. How many gallons of water is used for a 5-minute shower? And what about a 20-minute shower? So I want you to pause the video and write the question down and try and answer it. Okay, for a 5-minute shower, what you do is you start here, because this is minutes, you go out to 5, and then you go up to the graph. And there is my 5-minute shower. And what line is that? It's 5, 10, 15, and label gallons. So for a 5-minute shower, 5 minutes, 15 gallons. Cool. The other one, 20-minute shower. Well, then I'll go all the way out to 20 and up to my graph, which is here. And you see that that number over here is 60. So for a 20-minute shower, it's 60 gallons. Cool. Let's move on. What I want you to do now is look at point A right here, okay, and tell me what are the coordinates of point A. Then describe what it means in the context of the problem. Now that you're probably saying, what? In the context of the problem, in other words, gallons, minutes, what does that point actually represent? Pause the video. Okay, this is point 10, 30. Remember, you do your x first. So you go out to here, and it's 10. Then you go up to here, and it's going to be 25, 30. So that's my point, 10, 30. What does that represent? That represents 10 minutes, 30 gallons. Okay? And you could do 30 gallons, 10 minutes. You could write it the other way around, too. It doesn't really matter. All right, moving on along. Whoa. Here, can you use the graph to identify the unit rate or the constant of proportionality? Because again, they're the same thing. So, can you do that? Pause the video. Well, of course we can. This is no big deal, right? Pick any point. How about this one right here that we just did and we said was 1030. And then what we're going to do is we're going to say, all right, well, the constant is equal to y over x, which is 30 over 10. And the constant of proportionality then is 3. Pretty cool. Moving on. Plot the unit rate. Now you see I zoomed in on the graph here because you would never be able to see it otherwise. Plot the unit rate or the constant of proportionality on the graph. And is this point on the line? Well, we said that it has to be on the line in order to be proportional, so I'm kind of expecting it to be. So can you plot that point? And again, the k is equal to 3. Now if you remember, the points that have to be on are 0, 0, and 1, r, where this r here is your constant of proportionality. Okay, so in other words, this point is what I'm going to plot. Starting at the origin, I go to the right 1, and then I'm going to go up 3. Hey, look at that. It's on the line. Pretty cool, huh? Just like we expected it to be. Moving on. Now, what does point 0, 0 represent? Well, it's a good question, but I don't think it's that hard of a question. What does it represent? Think about that. It means that if the shower isn't being used, then it isn't using water. I mean, that's common sense, right? You have no minutes, you're going to use no water. That's what that means. That's what 0, 0 represents. Pretty easy? I think so. All right, last thing. I want you to write an equation to represent the relationship between the number of gallons used and the length of the shower. Okay, number of gallons used and the length of the shower. Well, if we're going to write the equation, we have to think about our dependent, our independent. We have to think about our constant. The constant we already figured out, though, right? We said that k is equal to 3. So our equation would say y is equal to 3x, where x is the minutes and y is the gallons. This is minutes, this is gallons. Now, what I want to do is just try it out. Let's try it, shall we? Let's say I use 15 minutes in my equation. Y is equal to 3 times 15. So if I go 15 minutes, I should use 3 times 15 or 45 gallons of water. So if I go on here, I go over to 15, and I go up to my graph. This point here, look it's 45. What? It works. It works. I like it. That's all. See you all later.